Okay, so next question says that the propagation delay of the XOR gate, AND gate, and the multiplier are shown in the given, which are equal to 4 nanosecond, 2 nanosecond, and 1 nanosecond. This is a combinational circuit question, so it's okay. We will do it if it is present in the slide. So if all the inputs P, Q, R, S, T are applied as simultaneously and held constant, the maximum propagation delay. So they have to calculate the maximum propagation delay. Similar kind of question we have done in combinational circuits also. So this is T. Right. So this is T. Depending on the values of T, we will take it 1. So case 1, when T is equals to 0, and there will be another case when T is equals to 1. So let's just take the first case when T is equals to 0. So when T is equals to 0, it will take this and this, right? Because it is connected to S0 for both. It's not inverted, nothing else. So S0 will become, when T is equals to 0, it will become 0 and it will take 0 input at a time. So now here, if we see this 0, but here mux 1 output is connected to 1, but it will not take as output. So this is not required at all. So what will be the propagation delay? So this after this, so that will be AND gate plus mux 2. So the total propagation delay, AND gate delay is 1 nanosecond, 2 nanosecond, and mux is 1. 2 plus 1, that is 3 nanosecond. Okay, case 2. When T is equals to 1. Now when T is equals to 1, it will be taking 1, right? It will be taking whatever input we are giving at 1. So here, if we are giving at 1, so this is what we will be taking. This is what we will be taking into picture, this and this. 4 things. Okay, AND gate plus mux 1 plus AND gate plus mux 2. Right, this will be selected because input is given by this AND gate given to mux, and then this again AND gate and this mux. They all are selected when T will be equal to 1. So what will be the propagation delay? 2 plus 1 plus 2 plus 1. So maximum propagation delay out of both of them will become 6 nanoseconds. So 6 nanoseconds will be maximum propagation delay. Right. Moving on to the next question. So next question says that for the component in the sequential circuit shown below, the TPD is propagation delay, T setup is the setup time, T hold is the hold time. The maximum clock frequency will rounded off to nearest integer in the given circuit to operate this. So in this circuit, things are given. Setup time, propagation time, hold times are given. So they are asking you to find out the maximum frequency on which it will be operated, the maximum clock frequency. So this is what you have to calculate. Propagation delay, we all know what is the propagation delay, time taken in order to give the output whenever the input is received. That is your propagation delay. Suppose this is clock. What is Suppose this is clock. I'm just letting you know what is setup and hold time. So setup time is the time taken when the clock is low. This is T setup. So setup time is the time taken when the clock is low in order to stabilize the output. When the output is stable, when the clock is active low. And the hold time is similar thing when it is active high. This is hold. So it is hold time is actually that time, the time needed to stabilize the output when the clock is active high, when the clock is 1. And setup time we calculate when the clock is 0. Basically all creates nothing but delay. in order to stabilize the output. Now in this case, we see two flip-flops, flip-flop 1 and flip-flop 2. Flip-flop 1 and flip-flop 2, there are gates connected, which is OR gate, and a NAND gate is also connected here. This circuit is little complicated given, but the solution is really simple. So whenever we are calculating the total propagation delay, how we can find out the clock? Basically, clock finding, they are asking a different question. In most of the question, they have given you clock and they will ask you the what will be the value of frequency of the output, right? This is the very common question. This is, they have given a little trickier question. They are asking what will be the clock. So basically, clock means what? Whenever we will be getting the next output, after how will be getting the next output. In other way, we can sense that that will be the clock value, that is the optimum clock value, and in this case we have to calculate the optimum clock value only. So total propagation delay, the maximum propagation delay, we can calculate by T setup plus propagation delay. We have to take the maximum values in the circuit. So setup time maximum value, in this it is 5, in this it is 4. So that will be 5 plus propagation delay maximum 3, 8, 2, 2. So maximum propagation delay will be 8. That will be equal to 13 nanosecond. So what will be the clock? After 13 nanosecond, we will be getting the proper output. So clock will be 1 by 13 nanosecond. If we calculate this, it will come around this 76.92 megahertz. It's that simple. It will come around 72.92 megahertz. So this is how we can find out the clock. We have to find out the total or maximum propagation delay which is there, and this we can find out the maximum setup, whatever the setup time. So there are only 2 setup times, so maximum setup time we can find out that will be 5, and the maximum propagation delay in the whole circuit. So maximum propagation delay is 3, 8, 2, 2. From among these 8 will be the maximum propagation delay. Add them up and find out the clock. Like after 13 nanosecond we will be getting the output. So clock frequency will become 1 by 13 nanosecond. That will be 76.92 megahertz. Yeah. Next question. Okay, this is again a state diagram question. In this state diagram question, very frequently asked question, they are asking you to find out the sequence. Okay, whatever the sequence this state diagram represents, right? So this is what kind of state diagram? There are 2 types of state diagrams. We represent there are 2 types, Mealy and Murray. So this is Mealy type. This is Mealy type state diagram. Mealy. In Mealy state diagram, we have multiple states. Here we represent output and input both. In Murray type, in these states only we represent the input, right? So here this representation x by y, x by y, here this is x, this is y, means x is input, y is output. So this is how we are representing it, how we are representing input and output in Mealy state diagram. So the first one is your input, the next one is your output. So now they are saying that you have to find out the sequence represented by this state diagram, and you have to find the sequence when the output is equals to 1. So output is equals to 1. So how we find out the sequence? So sequence is basically carried out when we are moving from one state to another. Whatever input we are giving, in moving from one state to another, that value of input is considered, right? So if we start from S0, let's see. So S0 will remain at S0 when the input is value is 1, but it is moving to S1 when its value is 0. So here the movement of state is there, the first movement, right? So the value of input should be equal to 0, sequence. So this will become our sequence, very easy. Sequence will start from 0. Now here S1 is there. If we are giving input as 0, it will remain at the same state, it will remain at S1 only. But if we are giving input as 1, it will move to the next state. So next value will become 1. Again S2. So S2 is like we have only one movement, no, two movements. So S1, when S2 is given 1, it will move back to S0. So this will go to the preceding state only. This is not required. We have to move to the next state. So these are the movements of the next state. S0 to S1, S1 to S2, S2 to S3, S3 to S4. Right? We have to move to the next state, not the previous. No, we don't have to go back to the previous state. So it will start counting from this only, right? We don't want that. So we have to move to next state. So it will be giving input 0. Now again we have to move back to next state. So next state is value will be equal to 1. Lastly they are asking you to find out the output. Now if value of input is equals to 1, it is moving back to S0. It's okay. But value when it is 0, it is giving back output 1. Output 1 means the sequence is completed, the sequence is detected. Sequence detector basically means there are a random number of sequence coming, input are coming, suppose 1 1 0 1 0 1 0 1 1 1 1 0 0 1. This type of sequence is coming. Now our sequence detector is a type of circuitry which act on a particular type of sequence. Suppose this sequence I want, right? This type of sequence I want. So it will start checking from this. Yes, it received. It will check this. Yes, it received. Yes, it received. Yes, it received. Yes, it received. Whenever it will receive the complete pack of sequence, it will give output as 1. So this similar thing is happening here. Now it has received the complete sequence. It is giving output as 1, and the complete sequence is this, because it is giving output as 1 when input is equals to 0. So this is your sequence. So this is how it will work. Suppose if this is a sequence and this is the sequence detector state machine, it will start detecting from this. Okay, so this will become 0, your output. This is some random sequence. So output here will become 0 0 0, because it need to detect, but it has started detecting from this. Yeah, 0 is there, it is there, it is there, it is there. Now here it see that a complete sequence is there, it will give output as 1. So basically it knows now that the complete sequence is present. Now here after this there is no such sequence is present, so output will always remain 0. This type of state diagram is for sequence detectors. Okay, moving on to the next question. Okay, so in the circuit shown, the clock frequency, that is the frequency of the clock signal, is 12 kilohertz. The same thing repeated again, so that's why I smiled. Okay, the frequency of the signal at Q2 is equals to what kilohertz? Okay, so they are saying that the clock frequency is 12 kilohertz, the frequency of Q2. So they are asking you to find out this frequency. So what will be this frequency? So in order to find out this frequency also, what we have to do, this is D flip-flop, and we have to find out the table, the sequence after how many clock pulses after which it is repeating itself. Right, the similar question this we did like previously. Okay, so this is an AND gate. AND gate output is equal to D1, and the inputs are Q1 bar, Q1 bar and Q2 bar. So D1 is equals to Q1 bar and Q2 bar, or you can write it like this, Q1 plus Q2 whole bar. Same thing, same thing. Now this is D1, this is D2, Q1, Q2. Let's just draw this. Q1, Q2, D1, D2, previous states. These are the previous state. These are the next state. Q1, Q2. Right. So previously let's just started from a reset mode, like it was 0 and 0. If it was 0 and 0, D1 will become, D1 is what? And D1 to we know D1 is equals to Q1 plus Q2 and D2 is similar Q1. So D2 is 0 and D1 is Q1 plus Q2. So this plus this 0 and that will be bar. This is your next state only. So next state is 1 0. So 1 0. D2 is Q1. Same. 1 plus 0 is equals to 1 and that bar, 1 bar will be equal to 0. This will become your next state. 0 and 1. Now this is Q1 is equals to D2. This is your 0. This plus this will become 0 and 0 0. So what is happening? It is repeating itself again. It will become 0 and 0. So this is clock cycle. Clock 1, 2, or you can start from this. You can say that if it is initial values, this is 0, 1, 2, 3. So after 3 clock pulse, it will repeat itself, right? Because it will become 0 0 and that pattern will repeat itself. So it is repeating itself after 3 clock pulses. So 3 clock pulses, that means the total frequency of output Q2 will be equal to, frequency of Q2 will be equal to total clock frequency 12 by 3. So that is 4 kilohertz. Whole will be your correct answer, right? So this is how you have to solve all these output frequency question by making this table only. There is no other option. You have to see that wherever the repetition is occurring, right? After how many clock pulse the repetition is occurring, and that much clock pulse, if you divide it by the original clock, that will give you the output frequency. So these are very common questions asked in sequential circuits. Find out the output frequency. So this is how you have to do it. Okay. Moving on to the next question. So next question says that a 4-bit shift register circuit configure right shift operation. So what is happening is shifting to right. So moving like this. Moving like this. Right. So that is saying that they have represented the operation also. A into A to B, B to C, C to D as shown. If the present state of the shift register is ABCD is equals to 1101, the number of clock cycles required in order to get the ABCD is equals to 1111. Okay. So there, this is what? This is a XOR gate, right? XOR gate is nothing but your DIN only, right? DIN value is given by XOR gate and XOR gate value is A XOR D, right? Now they are saying that it have started from A, B, C and D. It started from 1 1 1 1 and we have to reach to 1 1 0 1. Let's just start. Here I will draw clock also, because they're asking after how much clock. Start from first clock. So A XOR D. So that will become 0. 0 and 0 will be shifted to next. So it will become 0 1 1 1. 0 XOR 2 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up to 12 I can write. If it is more than 12, I have to erase from above and write it. Okay. So at first clock pulse, it will become 1 and 1 XOR will become 0, and 0 and 1 XOR will become 1. This 1 will moved here. 1, 0, 1, 1. No, this is not the sequence. 1, 1, 0, 1 we require. Again, 1 XOR 1 is 0. So it will be 0, 1, 0. So shifting is occurring, right? You understand that how in even question they have explained you the shifting. Like, let me write it here. So this will shift here, and this will shift here, this will shift here, this will shift here. This will shift here, this will shift here, this will shift here, and this will shift here. This is how a shifting process is occurring. Right. So now again we have to calculate the XOR. 0 XOR 1 is 1. So 1, 0, 1, 0. 1, 1 XOR is 0. 0, 1, 0, 1. It is 1, 1, 0, 1, 0. 1, 0 XOR is again 1, 1, 1, 0, 1. Okay, we got this. After how many clock pulses? There is some mistake, I guess, happened. Because it is not matching our option, right? It is either it is 5, 10, 15, 20. Okay, so at clock 0, the values are 1, 1, 1, 1. It is XOR. So 1 XOR 1 will be equal to 0. 0 will be moved to this 1, 1 and 1. Okay, 0 will be moved to A, B, 0, 1, 1, 1, 0, 1. XOR is 1, 1, 0, 1, 1. 1, 1 XOR is 0, 0, 1, 0, 1. 1, 0 XOR is 1, 1, 0, 1, 0 XOR is here. I have done the mistake. Sorry. So 1, 0 XOR is also 1, right? So 1, 0 XOR is 1. So it will be 1, 1, 0, 1. So after 5 clock pulses, only, we will get 1, 1, 0, 1. So this is how the process is occurring. So we have to XOR it and shift bit by bit. So after at initially it was 1, 1, 1, 1. After first clock pulse, this and this will become XOR. It will give 0 and it will shift. Again, 0 and 1 will become XOR. It will become 1 and it will shift. 1 and 1 will become XOR. It will become 0 and it will shift. Again, 0 and 1 will become XOR. It will be 1. It will shift. 1 and 0 will be XOR. Will be equal to 1 and it will shift and it will give the correct sequence which was asked after how many clock pulses? After 5 clock pulses. Okay, so these were 10 questions.